Good morning. I'm welcoming you. So ENIGMA, as you probably all realize now, stands for Evolution of Nanomachines and Geospheres and Microbial Ancestors. And the primary goal of this program is to understand the evolution of enzymes that transfer electrons with or without protons, the oxidoreductases, the origin of metabolism. Obviously, as my friend Nick Lane would say, and I think everybody in this room or in the audience realizes, the biggest, perhaps, as he would say, black hole in biology is the evolution of life. So we have been working on this problem for over 100 years. Operon and Fox at the beginning of the 20th century certainly espoused views on this. But experimentally, we have not come very close to creating electron transport chains that mimic or are precursors of metabolism. And that is one of the goals that we have in our program writ large. We have made progress, and there's still obviously a lot of things to do. Now, I just want to explain to you how we've structured the program. There are 3 themes. So the theme 1, which is headed by Vic Nanda, who will be up in a few moments, is focusing on the origins of the nanomachines themselves. What are the protein structures at the earliest, in the earliest metabolic pathways? And what do you do to make similar structures or design them and actually make them artificially, and how do they work? So that is a primary focus of theme 1. Theme 2, who is led by Jana Bromberg, who should be here in a few minutes, is looking at evolution of these structures using a variety of techniques, but it's bioinformatics, to be honest with you. That's what she does. And bioinformatics uses both structure and sequence to inform us about which metabolic pathways came first, second, third, fourth, so on. Now, many of the oxidoreductases that, in fact, all of them that transfer electrons contain transition metals. And a subgroup of those transition metals is used in biology in various mineral-like states, shall we say. So we have 4 iron 4 sulfur clusters. We have a 4 manganese calcium cubane, which is the center of oxygen evolution in photosystem 2. We have copper-containing proteins, and so on. And so going from how we went from rocks to life is one of the main areas, bridging areas, and that is the focus of theme 3, which is co-led here at Rutgers by Nathan Yee, and at the Carnegie Institute by Bob Hazen and Shauna Morrison. So without further ado, I am going to introduce Vic, who will introduce the speakers of this morning's session.